Welcome to Happy Path Programming. I'm Bruce Eckel.
I'm James Ward.
Well, hello. This week we have Luciano Ramalho, the author of Fluent Python, and the second edition came out just in the last few months, right?
Yes, in April.
In April. Okay, so quite recent. And you worked really hard on the first edition. And then you worked probably, did you put more time in on the second edition than the first? Because
I actually did.
That's the experience that I had when I was doing editions.
You would expect that the time amount would go down.
You would
with
think.
each edition.
I thought so.
Yes,
But,
no, that's one of the common illusions. Yeah, because
Yeah.
the later editions of Thinking of Java took more time than the first edition.
Yeah,
because you know more and you have to polish it and you have to change it.
And there were brand new things that I thought needed to be covered, but also there were things that I needed to rethink because of new features.
Mm-hmm.
Oh, right.
Like, for instance, there was already in the first edition a chapter about interfaces that talked about duck typing and the use of ABCs, abstract base classes and all that. And then between the two editions, now we have protocols in Python. So that's a third way of thinking about these same issues. And I really had to rethink. That was one of the hardest chapters.
Yeah. And Luciano is here with us in Crested Butte.
Live in Crested Butte.
Because he
Good to have you up here.
He likes to come here.
Thank you so much, Bruce and James.
This is like your fifth trip here or something like that?
I think so.
Yeah.
Mm-hmm.
Okay.
Yeah. Well, it's good to have you. And you've been doing Python for a long time.
Right? Yes, since 98.
Yeah. Wow. That's like a really long time.
That's when you discovered it?
Yes.
I've actually been using it longer than you.
Oh, yeah.
Wow. Yeah, but not as I discovered it, like, for me, well, I had only been doing C++, and then there was this Perl thing, and it was like, oh my gosh, it just worked. It just runs. Just, you don't have to do all this extra stuff. This is awesome. And then a couple weeks later, I tried reading my Perl code. I was like, I don't understand what I wrote 2 weeks ago. So then sometime after that, it was Python, and I don't even remember. The first version was 1.2 or 1.3 or something like that. So it's probably mid 90s that I started playing with it. But you committed.
Yes, I created a company right afterwards to leverage a framework that was called Zope.
Mm-hmm.
That became the foundation of Plone.
Yeah.
Mm-hmm.
Because I was doing content management work, custom content management systems, and that was really very advanced and very quick to do stuff.
Yeah.
So within 6 months of having first seen Python, I had a company where everybody was doing Python.
Wow. You were in.
Yeah.
That's cool.
So you started the company?
Yes.
Oh, wow. And how many employees did you have?
We lasted about 5 years, and in the end, we had 15 people in the payroll.
Wow. Okay.
But, then the web, that was in 99 that I started the company, and the web bubble burst.
Mm-hmm.
So things became much more difficult for us, and then eventually we shut down.
Yeah.
Okay.
Yeah, but we didn't owe anybody money.
So that's nice.
That's good.
That's a good thing.
So Bruce, he always brings Python into our podcast episodes, but now we really get to have an actual Python episode. So this will be fun.
Yes.
What I want to hear maybe from both of you, what do you like about Python? What drew you to it initially, and why have you stuck with it for so long?
Yeah, so it's nice that we started this conversation by reminiscing about 98 and 99, because at that time, I started doing web development in 94. And at the time, what you did was Perl, right?
Mm-hmm. Or C.
Yeah, but I wasn't into that. So it was one of those efforts that I've done a few times in my life I really want to like this language. So I did my best to like Perl. And then Java came along, and I was a Pascal person before, so I liked very explicit and well-structured things, and Java had that. And also Java was object-oriented, which Perl was not at the time. So I decided to try and really like Java very much also. But then when I found, so what happened was, at some point Perl 5 came out and it had some object-oriented features. And then in the Perl mailing list, it was a recurring theme that people were talking about how to solve a certain problem in Perl, in object-oriented Perl. And people would say, oh, in Python, this is how they do it. So after about the third time that I heard Python mentioned in that context, I went to look it up. And for me, it was just wonderful, because for me, it was like this clean, well-structured, really object-oriented language like Java, but it was also concise, and you could write little scripts that did interesting things in a few lines of code like Perl. So it was like, really, for me, Python was the marriage of the best features that I saw in Java and Perl, without most of the worst features.
Yeah.
I have gone through a whole thing because very early, the Python conference was run by this management company.
Yeah.
So, did you ever go to one of those?
Yes, in Alexandria.
Okay.
2002, I think.
Oh, okay.
Yeah.
And it was still being run by the...
Yes.
And every year they would say, oh, this is terrible. We're losing money on this. And then they would do it again the next year. And you're going, I wonder what your business model is. But at one of those, I gave the... I can't remember if it was the opening or closing keynote.
Mm-hmm.
And mine was why I love Python.
Mm-hmm.
And it was obviously popular. I was preaching to the choir in this case. But I was trying to go through and look at all the reasons that I loved Python. And just recently, I've kind of rethought all that, because those were, various technical features and things like that. But I realized, I think what I love about Python most is because of the way it treats the programmer in all ways, including, and so Python has the best community I've ever seen. And that came from what Guido did, his focus and everything, but also because his focus was creating a language that was nice,
approachable,
but I think really you can feel that the care for the programmer in that, and then it percolates through the entire community, and you can't you can't discover that your community has gone sour and fix it later. It has to be built in from the beginning, and that has to be the vision of the the group that starts it.
And that had a major influence on the history of the language. Mm-hmm. And I might even say the history of programming languages in general, because of the success of Python that still persists, right? If you look at Ruby and Python, which technically in terms of features and strengths and weaknesses are very similar, but Ruby is kind of in a decline and Python is still going up. Mm-hmm. Why was that? Because of machine learning. And why? Because since the language was approachable, in the 90s, people like Dave Beasley and others started to think, okay, Python is a very good language to orchestrate processing, heavyweight processing done in the sciences. So we already have these libraries in C++ and C and Fortran that do, linear algebra, statistics, everything. And now we just need the bindings so that people can write short programs and use those highly efficient things. So that was important, but it was kind of a niche in the physics, in the hard sciences. But then when this new approach to AI came about, which we call machine learning, which is based on math more than the previous approach, which was more symbolic.
Yeah.
Then suddenly, which language had the best ecosystem of libraries that already did all the math, and that was also high level and approachable. Yeah. So that's why Python.
Yeah, it was kind of in the right place at the right time.
Yeah, exactly.
But it got there because there was a foundation of people who cared about taking the math and wrapping it into
something that was usable
and copy and pasteable.
To people like physicists who are not software
engineers. They don't want to be
programmers. They don't want, exactly. Yeah.
Yeah, I'd seen this. Somebody did a study, or I don't know, maybe it was more anecdotal than that, but they figured out that most people that are writing Python code for machine learning, data science, that sort of stuff, they actually can't usually pass the software engineering, exams to get a job in software engineering.
Sure. Yeah.
Because they haven't been taught the like traditional
Sure.
computer science algorithms, data
Yes.
structures,
And even
but
the
they
tooling,
can
the tooling.
yeah,
like
the tooling, but they can do amazing things.
Yes.
And to me, that says so
Yes.
much about the language.
Yes, totally.
And the communities,
Yeah.
the foundations of.
So I always loved in going to Python conferences because of the diversity in the biggest sense of the talks. Because you had people like an oceanographer,
Yeah.
and a health professional, people of different areas of knowledge. Yeah. And of course, that was
they're domain experts.
Domain experts who are able to
huge variety of domains, but they've been able to use Python
exactly
to get their to help them get their job done.
Well, and I think part of that is the way that Python can interface with these other libraries on a low level, so that it isn't it's possible to take advantage of all of the stuff that's written.
Yes.
In those.
Yeah.
So Python has changed a lot over the 25 years or whatever that you all have been using it.
Yes.
Enormous changes. I don't know, like it's hard for languages to change. And especially like the Python 2 to Python 3 was kind of a big challenging time for Python. Like what has it been like to stick with one language for that long? Because I certainly haven't stuck with one language for that long.
Yeah, I haven't. Like whenever I need to do tooling for a book or whatever, that's what I use Python for that, because it's like the right tool for that job. But in the meantime, I've experimented with all kinds of different languages, and I don't know, every time I go back to it, it's just a delight. It's taken me this long to go, oh yeah, I've tried to write books on Python for the last, I don't know, for quite a number of years. And then it's like the Luciano's book is what I would consider, if I was to write, thinking in Java for Python, well, Luciano did that work for me. So I don't have to do that, which is a huge relief. So I can focus on something more specific.
Yeah.
So
let me just say something to that, because you don't know how much that feels good to me to hear, because I learned a lot about writing a book about programming languages, reading Thinking in Java. So that's really awesome.
That is awesome.
Nice to know that there's that secondary effect. Yeah.
What's the experience been like for you, Luciano, of like moving through all the language changes, and how has that gone? And
well, okay, so the one thing that I like to emphasize, because of this long-term view that I have of the language, is that the Python 2 to 3 breakage was really a one-time event. I was using Python. I started, I think, in Python 1.4 or 1.5, and then there was the migration to Python 2, and most everything just worked.
Yeah.
The thing about the migration to Python 3, I think the main reason was was making Unicode a first-class citizen in the language. It already had pretty good Unicode support, but you had to remember, for instance, to put this undercase U in front of your string so that they would be understood. The string literals would be understood as Unicode. And
there was a lot of weird error messages that you would get too.
Oh yeah. Well, that's
really annoying.
Yes, that's right. And so I think that was a positive change. I know it caused a lot of pain.
It was like at some point it had to happen.
I think so, and it had to, because it was really difficult to explain to people beginning programming. Oh, so you have bytes and Unicode. Most of the time, people want text. Text is Unicode, right? Yeah. It's rare that you need bytes, right? Often, people do web programming, and the frameworks do the text to byte conversion for you. So you're just in this happy world where everything is text. But And that was so there was an assumption that a lot of the migration could be automated. They created this tool called 223,
Okay.
but that particular thing couldn't, because it required understanding the semantics of the program, whether this string is being treated as text or bytes.
Right. Yeah.
You know?
Yeah.
And so that was the main thing that people really had to do manually.
Yeah.
Yeah, but weren't there some other, core changes that they made, which to enable some of the features that we've been able to add since then?
But they were all, I agree, but they were things to make the transition less painful, but still to support gradual transition done manually.
Mm-hmm.
The automation, I think there was a lot of expectation about that didn't pan out.
Yeah.
But another thing, so about other things, I would say I think the three major things that we saw. So today, this is kind of a detail, this thing about Unicode. I'm really glad we are past that.
Mm-hmm.
Okay. Yeah. The second thing was the implementation of a way of doing asynchronous programming, a modern way, copying a lot of the idioms and keywords from C#, like await, async, things like that. And of course,
but that didn't happen till way later.
No, yeah, sure, but I know.
But you're saying the
I'm talking about
changes.
the things that I felt made more, had the biggest impact.
Mm-hmm.
And yes, and
that was like the 3.6 time frame.
3.5.
3.5 is when they added async await.
Or actually 3.4 already.
Okay.
But there wasn't the keywords weren't there, but the idea was there, but with a different keyword. Okay. And then in 3.5 they introduced the keywords.
Okay.
They had this keyword called used from, which did what await does, sort of. Yeah. Huh. But that lasted only one version.
Yeah. So there's been some pretty disruptive changes, but pretty minimal in terms of like, oh, now I got to like rewrite this code. Most of the changes seem pretty incremental. It's like, oh, a lot of the PEPs, right, is what they call them, have been just making it so that that your code would still work, but they've added a new feature that enables something new or makes a better way to do things. Like they added ADTs, they added optional static typing.
Exactly. That's the third thing.
Pattern matching.
The third thing that I would say is now the support for static typing. But so I always like to tell people, because Python became Python's popularity grew slowly, right? Because there was never a big corporation behind it advocating for it.
Well, and the general attitude, I felt like, was always, oh, if you don't like Python, don't use it. There was no, you've got to use Python.
But maybe because there was no corporation. If there's a corporation behind pushing it, somebody's job is to, exactly. Yeah. So it grew organically and slowly over many years, but it was kind of famous when this migration to Python 3 came about. So people got this is very flaky. But no, so what I want to convey is that this was a one-time event, and everything that I observed in practice before and after that is very incremental and trying to do as little disruption as possible with the previous with existing code bases.
One of the big challenges I remember in that 2 to 3 time frame was the library ecosystem. It was a bit of a chicken and egg that took years to kind of get through. And libraries were a key part of it, because libraries are such an important part of the Python ecosystem.
Huge. Totally.
And getting the libraries all to migrate took other libraries upgrading, which took others. There was just this chain of events that just took a long time to play out.
And this is very interesting, because people anywhere in any language community that needs to deal with this kind of disruptive changes in the language, it is interesting because the idea that actually enabled that migration for big frameworks like Django, let's say, was not the 2 to 3 conversion tool, which would help them maintain 2 code bases, but it was libraries like 6, which kind of created how do you call them? There's a word they use in JavaScript a lot for that. Shims, I think.
Oh, right.
Right?
Yeah.
So ways of expressing things that would work in both languages.
Right. Creating a
Which
common
are not,
layer across both
they are
2
not
and 3.
idiomatic Python 2 nor idiomatic Python 3, but ways that you would do things that worked on both.
Polyfills.
Polyfills.
Yeah.
Oh yeah. So they invented. So that was what 6 was about. So they were able to do that with.
Okay. So they had to get
Django.
the ability to do polyfills.
Yes.
Then they had to get the polyfills in place.
Exactly.
And then I'm sure at this point you don't really need the polyfills anymore, but maybe you do in some cases. But
no, not now. Not now. As soon as you drop support for Python 2, then you start removing that stuff.
Yeah.
Mm-hmm.
But there still are companies using Python 2, yeah?
Yeah, there are, but most of the big frameworks are not supporting it anymore.
If you want to be on
because the core developers are not supporting it anymore. So it's
it's officially deprecated at this point. Yeah.
Mm-hmm.
Yeah. So
so what other
let's segue into the topic of static typing, because one of the things that I learned when I studied this is that the big corporations that have huge code bases, that for them converting from 2 to 3, the static typing helped a lot in that effort. So that's a tip to the listeners. If you still have a code base in Python 2, you have to invest in adding type annotations, which are more cumbersome because the syntax
you can add the
is
type
not
annotations in too.
Using scripts, using comments, and also other things. But mostly comments.
Okay.
And also what they call.
So first add some static type information.
Yes.
And then after that, then it'll make your migration to 3 easier.
Yes, because one of the things that you have to decide when you do that is whether this is really bytes or string, for instance, and make it explicit and have the type checker, analyze the flow of your logic and say, no, here you're using it as text, but over there you're using it as bytes. So you need to do a conversion somewhere. That would be a type error, right? Yeah. So this is a good, useful tip for people who are still working with Python to investigate this. So the other way, besides doing comments, is to do. It's I forgot the name now. It's like header files, but it's just files that have stub files. They're called. And they're files that only have declarations of functions with their signatures.
Okay.
And the type hints there.
Like the pound includes in C and C++.
Yeah. Because the Python interpreter, the Python 2 interpreter can't read that syntax, but the type checkers can, so then it works.
You have to say, I've just become more and more of a fan of the type annotations. I mean, just for one thing, it's just readability.
Yeah.
Because, you can see, and it's really nice.
Yeah. I agree. I also became a fan. But although I am kind of maybe more known as somebody who criticizes, but I think it's because I feel we need to find some balance in the messaging about that. Because, for instance, when we talk about scientists, or of all kinds, for them the cost benefit of having type hints is different.
Yeah.
The cost is much higher because of the kind of abstract thinking that they have to do.
Yeah.
To think about types and a
lot of times I'm sure that they're not even sure what their type shapes should be.
Yes.
Because they're iterating
exploring
through
it. Yeah. Exactly. And then and also they usually work in very small teams and even alone a lot of the time.
Yeah.
So that's different, and that's why I think it's dangerous that we shouldn't, as a community, be stressing too much that as the right way of doing Python, because it can have bad consequences, of having instructors telling that to people when they're teaching Python to scientists.
Yeah. See, this is this thing that I thought of in the middle of the night. Tools, not rules.
Yeah.
This is another example of that. It's like, it's a tool. It might help, but it might get in your way. So, do what you need. And then maybe later you'll discover, this is actually really helpful.
Yeah.
And I think the evolutionary thinking that Python allows, you can start with the simplest program, you get results. And then as it you learn more stuff and it's there.
Yeah.
You know, it's like, well, the thing that you showed me yesterday, the single dispatch mechanism, it's like, oh, I didn't even know that was there.
Yeah.
Yeah, the incremental learning is huge for Python, because we were talking a couple days ago about how many concepts you need to understand to get to, let's say, hello world.
Oh yeah.
And for Python,
Yes.
is it two concepts?
Yes,
Most languages that I work with, it's probably in the realm of 20 to 30, maybe more concepts to get to hello world.
Which for a new programmer is, it's like, oh my gosh.
Or a data scientist who doesn't need all the features.
Oh, right.
It's like, do you really need to understand, I don't know, inheritance to to do data science most of the time? Probably not.
No, yeah, exactly. Yeah.
Or variance.
Well, and think what it looks like to a new programmer. If you have to learn all the concepts that you do in Java to get to hello world, you're thinking everything is going to be like this. Right. It's something this simple. It takes this much. Everything else is going to be, this isn't for me.
Yeah.
You know, I think it drives a lot of people away. You were saying that Brazil has the most, where you're from, has the most, what is it? PyLadies groups. Yes. See, and that's interesting. The fact that Python has, there's Django girls, there's PyLadies, there's all these things.
In Brazil now we have, it started in Brazil, but it's growing elsewhere, AfroPython. Yes.
So all these things that are for specific groups.
Yes.
So that if you're thinking of becoming a programmer and you go, oh, there's something for ladies or African Americans or whatever. It's like, I'm going to feel more comfortable there.
Sure.
And it's like, do we see this in the other language communities? This is one of the things I love. You know, it's like, how do we make it even more welcoming than it is?
Yes.
And I love that it does that.
For everyone.
For everyone. And that's
sure
just
that everyone feels like they have a place.
That
they fit. Yeah.
And for instance, and like you said, it comes from Guido, because I've watched a few keynotes from Guido live, and in most of them, if not all of them, he was always wearing the same really old T-shirt that had this toddler working on a computer with an old CRT, and the text said, "Python is for girls." 15 years ago, he was already using, and it looked worn at the time.
was that a T-shirt, you speculate, created as a knock against the language or something? Was that
no.
Okay.
Exactly. It was just
it's
whereas, you know, I especially when the shirt was made, it was like, well, computer programming is for boys.
Yes, exactly.
And this was a knock against that.
Yes, exactly.
It's a marketing message for Python.
Yeah,
but why Python was awesome and inclusive, but
without marketers involved. It was just but the point is, like, that's always. And I remember at one point he said, "I want half the presenters at the conference to be women."
Yes.
And it's the highest percentage of any conference that I've seen. I don't know if it has reached half.
And also in one of the keynotes, he said, when they opened for Q&A, he said, "I'm only going to answer questions from women, because, you know, you guys have a lot of opportunities."
Wow. Nice.
So what have been other kind of big changing awesome features in Python over the 25 years or whatever that you all have been using it?
So I think a major change was incorporating this idea of iterables more deeply into the language. That was something that happened in the 2 to 3 transition. And I think it's super elegant, you know, the way that lots of stuff are lazy iterables.
I like generators.
Yes, exactly.
I've just been coming more and more.
Exactly. Yeah.
Can you give a description of what?
So a generator is, that's the thing. I'm still kind of mulling over it, but basically it's a function that instead of returning, there's a keyword called yield. And what it does is it basically suspends the function. It returns a value. When you call it again, you can pass it a new value. And this is why when they were starting to look at coroutines. They were going, oh, a generator is kind of like a coroutine. It's
like a stateful continuation.
well, a continuation is stateful.
Yeah.
So it is like a continuation because it's like, okay, you start this function. It has it also captures it's a closure, so it captures everything around it.
Yeah.
So it's really this object that you can suspend when it returns a value to you.
When you ask it,
but then
you can ask it for things, and it
and then when you go back and you go, oh, I need another thing from that, so it's automatically lazy evaluation, and it's doing, instead of just pulling things off of a queue, it's actually doing some calculations to produce the new value. It's really,
but it can also be pulling something out of a queue.
Oh, sure, sure.
So it's
well,
but it's not really. It's more limited than a continuation because it's asymmetric.
Mm-hmm.
You know, it can only yield back to the same place where that started it.
Mm.
You can't jump to another. It's more constrained. Than
So typical use cases for this are you have essentially some data stream of values, and you need to then do some lazy operation or
think about a map operation, which is very common. So map in Python 2 produce a list of the results, and in Python 3 it's a generator. So you just
it's similar to like a stream, and
it's like a stream. Yes, exactly. And so generators then grew up into coroutines by leveraging this other mechanism that Bruce mentioned, which is the ability to collect not only yield data while it's running, but also collect input from the client code.
Okay. Yeah.
And then in a coroutine, it mostly works then that other way. Because then you do asynchronous programming without callbacks. Because what you do is you yield to the event loop, and the event loop will let you know when something is done that you needed.
Now I have something for you. Yeah. So then probably the async IO stuff rebuilt on top of that, because Python had some async IO before that, but it probably was not as elegant. And
well, it's like they did several experiments before they arrived at this one.
Well, it's interesting because Twisted Matrix, the most famous and the oldest, not the old, I don't know, it's one of the oldest, biggest frameworks in Python. Was it's about asynchronous programming, and it was already like 20 years old when async IO was developed.
Okay,
and it was influential. Guido wrote about how he talked to Leif Lefkowitz, the main author of Twisted, about how things should be in async IO.
Although I tried to learn async IO, Twisted way back, and I think I understand why it was so confusing now, because they had to create, you go into it and you go, all I want to do is this thing. And they go, well, now we have this whole set of libraries and all these different, I'm going, why? And now I understand why, is because they all have to be worked that way. But at the time, the book that I was reading didn't really explain that. So it just seemed like this huge mass. And
But so, and it's interesting how, for instance, we were talking about being accessible and approachable, and you see this happening again and again. So now we have Pablo Galindo Salgado, who is one of the core developers and currently the release managers for the main versions now. He's doing an excellent job of making the error messages more understandable for people who are beginning.
Rust really, I think, helped us all to see
set the bar.
Set the bar for helpful error messages.
I was just both Luciano and I have been playing with Rust yesterday, and that was, I had this experience where I'm going in trying to get this example to work, and Rust goes, "Oh, this isn't right. Try this," and I go, "Okay." All right, that worked. Now try this. And it's like, oh, and it works now. And it's like, whoa. That's brilliant.
The other thing that I was going to mention about being more approachable is how documentation for async.io changed radically between the time that I wrote the first edition and the second edition, because Yuri Selivanov, who is a great contributor to this asynchronous aspect of Python, he did a major reworking of, he just completely re-edited and made it more approachable, because the first iteration was more like, okay, so this is for asynchronous programming experts who are going to develop the libraries on top of this stuff.
Yeah.
So it was.
Are you talking about the Python documentation?
The official Python documentation for async.io originally was like that.
Yeah.
Was for people like Glyph. Okay, so now I want Twisted to support this, and this is what I read. So it was very,
it's for experts.
For experts, yeah. And then now it's really much more approachable. Has more examples that you can copy and paste to get started.
And the library ecosystem has probably come along too, where
totally.
support the async.
Exactly. Like for instance, now there is this library called. So it's interesting because almost every example in the first edition of my book still works, except those that use the asynchronous programming, because the APIs changed so much. It was provisional when I wrote the first edition, and one of the things also that changed was, for instance, I have a sequence of example where I do this task of downloading a bunch of images sequentially, then with threads, then with processes, which is not really the right way to do it, but just to show how the API is similar. And then with the synchronous programming, that's completely different.
Yeah.
And I had to use two different libraries to do that, because there was the blocking one that I could use with the first three examples, and for the synchronous programming, I needed another completely different library that had a completely different API. And now in the second edition, I was able to use this wonderful new library called HTTPX, which emulates the API of requests, which is the most popular language. Library to do that for HTTP clients. But it also works with it has the same API adapted for asynchronous programming. Then the code looks.
So whether you're using requests or async underneath the covers, you have a similar API.
Exactly. That was good. So that's one example of what you just said.
Where the library ecosystem got up to, embrace the async IO and nice.
Yeah.
What about ADTs and pattern matching? Where's Python at with?
Yeah, so pattern matching is a new feature that came out in Python 3.10, and I loved it in other languages that I learned before Python, not before Python, but before writing the second edition, like Elixir, which I've been playing around for a while. I really loved that feature. And in Python, I thought it was kind of strange at first. There's a lot of corner cases, because in Elixir, it feels very natural because it's really built into the language, right? It does pattern matching automatically on the function arguments. There's no keyword to do match, right? That's how it works. It's just, and then in Python, it's a very nice feature, but I think I've never taught it to beginners. This is something that I still need to do to appreciate the complexities, or maybe it's just my imagination that it's complicated. But I find it a little bit disturbing that it reuses syntax in a way that, for instance, everywhere in Python code before pattern matching, where you saw, let's say, int open paren x close paren, you were building an integer object out of x.
Yeah.
But when that occurs in a pattern, it doesn't mean that.
Right.
It's a type assertion.
Yeah. But that's saying that inherent to all pattern matching, at least that I've seen.
Yeah.
And that's just a thing, that's just an extra thing to start getting used to. Yes. But anyway, you had to get used to that too.
Exactly.
That's an extractor, value extractor, or whatever. Mm-hmm. You can extract the value out of that. Is that what that?
Yeah. No, it matches on the type.
Yeah. Matches on the type and then pulls.
Oh yeah, there's this. The extraction is wonderful.
Yeah.
I think it's one of the best parts. I like when I was doing research, I found to show examples of pattern matching. I found an example by Guido that's really interesting because it's a match case statement with only one case.
Mm-hmm.
That's he's using just to unpack the thing,
right?
Because it becomes it becomes like a declarative language to extract this information from nested deep down. And so that's very, very readable, and it's just one case.
And maybe Python has this as well, but in Kotlin you can say val and then open paren x comma y comma whatever, and then that will destructure the thing, the object into the pieces of it.
Python is like that, but you don't use the val.
Yeah.
Okay.
When you use just a bare identifier.
So why would you want to, if it seems like those are similar things, the example you gave with the pattern, the case match case, and the extracting out the values out of it.
Yeah.
Why would you want to use just a single one over the destructuring into values?
Because Python doesn't have that destructuring normally. It's only within pattern matching.
No, it does destruction of iterables or sequence-like objects.
Okay.
That's
but not of objects.
No, but it doesn't pull them apart. It doesn't do the thing that the match will do.
Yeah.
So
okay. Yeah. So there's the powerful pattern matching now, which is great.
Mm-hmm.
So you can match on the type.
Yes,
which is the example you gave with the int.
Yeah.
And then you can also destructure in the pattern match. And then other parts of that DSL as well.
It's mostly, I mean, my understanding is that it follows Scala pretty closely.
Yeah.
I don't know if it even, I mean, I think that was the model.
So I think that there are some types in Python now. So can you then do an exhaustive pattern match on the sum type? And
yeah, it's really nice. I mean, it feels like the two sort of go hand in hand to me.
Yeah.
And it's like, here are all the types.
Yeah. Some types in pattern matching.
Which I didn't see at first, when you just look at it by itself. But if you look at it together with pattern matching, it's like, oh, of course. But it feels like a different kind of polymorphism to me.
Ooh.
Yeah, some type polymorphism I've just started calling
Since you've been working on your talk for Strange Loop, everything is a form of polymorphism.
Well, kind of. It is occupying my consciousness very heavily.
Yeah. Any other major interesting features or game-changing things that have happened in Python that we should highlight before we talk about what's next? Or
let me think.
Yeah, and obviously,
I mean, there's a lot of things. Well, and they
just so many little things. I think is the thing that Python has also done well. It's just
it's got a lot of little things, and you see those in Kotlin. Kotlin picked up a lot of features from, but
and Rust too.
Yes,
I was reading it, and
it's inspired a lot of languages. Well, I've seen support for functional programming. I mean, you still have to, there's no in the data classes, because that's a feature
that's a new one.
Data classes has an option to make the elements frozen,
immutable. Or
I mean, it's not. It's sort of like what Java does with the immutable collections, which is it throws an exception if you try and change it.
Yes,
but it's still, the intent is there, and that's nice. And then there's libraries for the func tools, and then people have gone on and created additional func tools libraries, and there's some of that stuff is pretty clever.
Well, there's Lambda syntax that was added at some point.
No, Lambdas were there right at the beginning, and it's pretty awful.
Yes, it's still awful.
Yeah, it is. I mean, because when you think about what a Lambda is for, it's the smallest amount of code to express a function.
Yeah.
And with Python, you say Lambda. You spell out the word Lambda : and
it's still, the body has to be only one expression.
Yeah.
So.
But
going back to data classes, I think that's a feature that's very popular. And you mentioned frozen data classes. There's also now typed named tuple, which uses the same kind
that predated data classes.
Yeah, but now you can use the same syntax of a class declaration.
Right.
So that you have this alternative when you want the thing to be immutable.
Right. Right. Yeah. But then you can't add. I mean, data classes.
You can't. No methods. You were gonna say?
Yeah,
no.
I think so.
Yeah, you can, because now there's the syntax, right? That what was missing was the syntax.
Oh.
Now that you can write class, student, and inherits from.
I know I looked at this because my presentation at PyCon was on data classes.
Oh, yeah.
And then I looked at name tuples, and it was like, oh, yeah, this is very similar, but it definitely had some things that data classes, I mean, it couldn't do things that data classes do.
Sure.
Yeah.
But I don't remember. Yeah. But I think the things that the data classes can do that are really advanced in terms of daily usage.
What's in the standard library in terms of like collection operations, like map, flat map, fold, traverse?
A lot of that, and then like functools, the module that he was talking about, has a lot of functions that are also generators that are really inspired in Haskell. I don't know Haskell, but I was the guy who wrote most of that library, Raymond Hettinger, studied Haskell and then basically brought the main constructs there.
Okay.
Yeah.
Huh.
Yeah.
Nice.
Yeah.
It's very nice.
So there is some nice.
And it's highly optimized. It started as a pure Python implementation, this library, but now over the years, almost all of it, if not all of it, is now in C.
Okay.
Right.
Yeah.
Right. Yeah. I just came across the thing where you can discover what's in the core when you load Python is already there as C libraries. And then all you're importing is really the declarations.
Yeah.
And one of the other things that I've struggled with this over the years is writing Python extensions, because you can write Python extensions that are originally Python was all C, and so the extensions would be in C, but to understand how to do it was just, and people have tried over the years to create better and better ways to do that.
Yeah.
And Jeremy and I experimented with Rust to create Python extensions, and I'm pretty sure if I ever needed to do a Python extension, I would use Rust with the PyO3 library, because for one thing, if you're writing an extension, one reason is for performance.
Yes.
And Rust is going to be flat out you know, it's like you're not going to go to the trouble of writing it in some language. Oh, it's not fast enough. It's like if it's not you know, if it's not as fast as you need it in Rust,
your
you
reason
need
to take the escape hatch better be valid.
It's funny. I've been using Python since '98, but still, I never wanted myself to spend the time to learn how to do an extension. But now I do because of Rust.
Yeah.
Because I know that it's going to be safe. Because the problem is you're
memory
changing
garbage collector,
objects that are really managed by Python itself. So you have a lot of opportunities to break things and do leaks. Core dumps, which are core dumps are something that are not part of the experience of a Python programmer, right? It's almost impossible to core dump the interpreter. But if you do an extension, that's very easy.
Yeah. So right, because Python is
you're on your own. Good luck.
Right.
Hope you remember to malloc and deallocate whatever.
Well, there's that, and the fact that Python is managing the lifetime of all these things with its garbage collector.
Yes.
And then you go out into an extension.
Yeah.
And you got to interact with that, and this is why the global interpreter lock exists.
Yeah.
So I wanted to ask about the GIL, the global interpreter lock.
That's a good subject.
Yeah, can you?
Well, let's talk about it. Let's stop there and talk about the GIL.
Just explain it first for the people who don't know Python. Yeah. Explain what the global interpreter lock is, because.
Great. So the interpreter, as it's running, is handling all of these objects that your code creates, and there's, like Bruce just said, there's a garbage collector, and it's based on reference counting, and so a lot of these inner data structures that are essential for the proper functioning of the interpreter are not thread safe. So there's this lock called the global interpreter lock, which any code that wants to change those structures has to acquire, right? And also, of course, that applies to the extensions themselves. So essentially what this means is that, and one of the codes that acquires that lock is part of the interpreter, the part that runs the bytecode.
Right.
Which means that because of this, the Python bytecode can only run on a single thread. So it will only use one of the cores on your machine. So that's the GIL. I think it's important for, like as an advocate of Python, when I talk about that, I have to say that it seems like a very bad feature, but it's also something that simplifies a lot the interpreter itself, which is why Ruby also has that. And
it seems like any interpreted language. Like I don't know how you could possibly have an interpreted language that wasn't single-threaded, essentially, at least on the. Well, you
can, but then you have a cost when you're running programs that don't need more than one thread.
Right. Yeah.
Which, when Python was created, was not an issue, right? Because in the 90s, multi-core computers were called supercomputers, not cell phones,
not Raspberry Pis.
No, yeah. So the use case. So this is still an obstacle. The community, the leadership in the community says, okay, any proposal to get rid of the GIL must do it in a way that doesn't impact the performance of single-threaded programs. Yeah. And maybe if this requirement was already there, for instance, when the Go language was created, they wouldn't be able to. So you have to, if they've started with something that was already thread safe from the start, it would have been slower, but people would have gotten used to it over the years. And anyway, so this is the GIL
coordination.
Yes, and the GIL also makes it easy to implement. Not easy, relatively easy to implement extensions, right?
Yeah.
Now, as an extension author, you can be smart about that and not just grab the GIL, do your thing, and release the GIL, because you can. You can, for instance, okay, so this is computationally intensive. I can actually run threads from C, and I will release the GIL while those threads are working. And so a lot of the numeric ecosystem in Python does use all the cores that you have, because the libraries are built like that
through extensions, and through explicit GIL control.
So the GIL exists, and it's a downer, because, for instance, that means that large-scale asynchronous programs. So here's the thing that I learned. The people say, "Oh, this is an I/O-bound system, so I can do it in Node or Python asynchronous, Python async I/O, because it's an I/O-bound system." But what I learned is that's an oversimplification. There are no I/O-bound systems. What you have is I/O-bound functions. Systems have a mixture of I/O-bound and CPU-bound functions. And as they grow,
a lot of times it's just shifting from, this part is I/O bound, and this part, then we shift it. This part is CPU bound.
So there's a failure mode in the evolution of systems that are built asynchronously with a single thread, which is the model of Node and Python, for example. The failure mode is, as we add features, the thing gets slower. And why is that? Because the little tiny CPU intensive functions that you have are having, each of them is pulling the handbrake of the main loop, the event loop, a little bit further. And so, for instance, it's a very interesting example. So Yuri Selivanov, who I already mentioned as a major contributor to Python asynchronous programming, he created this. So the Python async I/O is a library that has a pluggable event loop. It's designed like that. They define this interface for the event loop so you can implement others. And he implemented one on top of the event loop that is used by Node, which is highly optimized, and it's written in C++. So he wrote a Cython wrapper. So Cython is this thing that compiles a superset of Python to native code.
Yeah.
So he wrote a Cython wrapper around the Node.js event loop, and he called this thing UV loop, and he wanted to show how performant it was. And he has a benchmark that showed at the time, about 4 years ago, that it was nearly as performant as Go. But to achieve that result, he had to do something. Of course, for a very simple benchmark that is not realistic, he knows about that. He wrote about that. But when he was profiling, he noticed that the library that he was using for doing asynchronous HTTP had a slow HTTP header parser.
Right. Yep.
So that was the CPU intensive. So this was a super stupid benchmark of just serving 1K byte blobs.
Yeah.
That's all it did.
This reminds me of...
but the parsing was CPU intensive.
Yeah. This reminds me of, remember the Tech and Power benchmarks, which they're not as interesting or, I don't know, as they used to be. But I remember there was a time when there was this big arms race in seeing who could be fastest on the Tech and Power benchmarks. And all of a sudden, some library framework, whatever, shot up above all the others. It's like, oh my God, how did you get so fast? Oh, we just don't parse the headers of the HTTP request. Awesome, you're so fast and totally useless.
Yeah. So what Yuri did was he then went to all this other trouble of wrapping up, also in Cython, the HTTP parser in C++ used by Node. So he had to develop this other library, and that's how he achieved near parity with Go.
Yeah.
But anyway, so the point is that the GUI is really hurtful because of that. It makes your life complicated when...
Well, it makes you want to do as little in Python as you possibly can, which is kind of...
Well, if you're worried about performance.
Well, in terms of concurrency for I/O, it's a lot of things, right? Yeah. So you have to keep your... So one suggestion that I make to people who do a lot of asynchronous programming in languages that by default only support one core, maybe this applies to projects in general, but for those particularly, you have to have in your CI pipeline a way to detect regressions in performance. Because that has to be addressed immediately.
Because it could be some developer added some code, and all of a sudden that has really pulled on that guild handbrake, and now it's affecting everything.
Because if you wait until all the developers are kind of bothered about it, then the problem is already maybe too widespread. I actually saw a project die because of that.
Automating kind of detection of guild issues is
overall performance with I/O, with yes,
that makes sense.
Or performance in general.
Yeah, sure. Yeah,
I have had numerous situations where I thought I knew better than Python when it came to performance. I go, I don't want to do it this way; it'll be slow, which was, dumb in the first place. But then I would discover that, oh no, actually, if I do it what looks like the slow way, it's the fast way.
Yeah.
And that has to do with that approachability attitude that you mentioned. Because, for instance, people say, oh, you should never concatenate strings because it's a square. But the thing is, they know people do that in reality.
Yeah.
And since strings are immutable, they actually implemented this thing that, we over allocate.
Yeah.
And then when they do that, when we can, we just add the content right there.
Yeah.
So it's not O2
I
anymore.
think Java does the same thing.
Yeah.
It's like they didn't used to. You used to have to use string builder because concatenating strings was too slow.
Yeah.
And so then everybody had to use string builder. But then at some point they're just like, let's just make it so that underneath the covers we do
because
do the optimization for the user.
Compiler, right?
Yeah.
Do your
it's similar to like automatic transmission versus manual transmission. Right?
Yeah.
Yeah. Of course, the manual is more. If you know how to use it, that's the point.
Oh, yeah,
That's right.
Then
Yeah,
it's more efficient.
Yeah.
I really like a story that I think exemplifies this whole attitude. That because sometimes people say, no, people never need to understand this thing about concatenating strings and do it right. Okay, they deserve to be punished by slowness if they don't do it right. So I remember
punishing compiler philosophy.
Yes. So I remember the first time I installed Debian in the 90s. So I had this, like this, how do you call them? This PC that I just assembled out of parts. How do you call them? There's a name for this here.
Kit?
No, yeah. Anyway, and I didn't know the brand of my CD-ROM. Right? It was just a random X brand.
Linux needs to know that.
The thing is, then the machine booted from the installation CD. And the installation, I went through several screens. Everything was working fine. And then it asked me what exactly was my CD-ROM drive. And gave me 400 options.
And the version.
Really, 400 options. And there was no option that said, please use the driver that's already working.
Right.
Please. No. I just had to give up because I didn't know.
Yeah. I did that many times when I tried to install Linux.
And it's just stupid. And then when I talked to a Debian advocate about that, he said, no, but you would be using a suboptimal driver.
That's right.
But at least it would work, man. I would then be able to connect to the internet and do everything else and be able to learn about that shit. And maybe I would never need a faster CD-ROM driver because it's not really so important, right?
Yeah.
No, but it would be suboptimal. So
this is exactly why we call this happy path programming, is that we want the happy path and the right path to converge.
Wow, that's awesome. Yes.
So I have two more things I want to talk about. One is the probably still out there, Python is for scripting, and you can't build big projects with it. And I think there's a lot of people who still have that attitude. What's your?
No. I think that attitude now is completely forbidden because we have static typing, and that's what's supposed to be the thing that prevented Python for being used.
Was it? Okay.
I think static typing makes a huge difference there.
Yeah, it helps a lot.
Yeah, so that attitude is...
So we can...
for large teams and large code
bases. Well, and then there's also the performance concern.
Yeah, the performance concern is a
horizontal scaling.
But Jeremy's company, what's Jeremy's company called? I forgot. It's the security company. He says we've never... That's the performance has never been an issue for us, and they run big systems.
In Python?
Yes, it's all Python, except for one Rust extension that he wrote.
Yeah, nice. Yeah. So they took the escape hatch when they needed
it, and it speeded things up dramatically.
So this is interesting. One change that I made in the second edition of the book was because talking about the GIL and its limitations it's always kind of depressing. Right?
It's a downer.
Yeah, it is a downer. But then I wanted to explain to my readers so despite that, YouTube was built on that, Instagram, the backend, and a lot of
on Python.
Yeah.
So how do you
reconcile?
How do you reconcile that?
Is the GIL as bad as we make it out to be? If people have been able to work around it, or it hasn't been an issue, or
exactly. So that's what prompted me to create this chapter that didn't exist in the first edition before the chapters that talk about threads and processes and asynchronous programming. This one is called Concurrency Models in Python.
Mm-hmm.
And it starts with a contribution from Bruce, which was great. His insight that I mentioned there, that one of the challenging things of doing concurrent programming is that when you call a function in sequential code, you know when it's done because that's when you get the result back.
That's right. That's when your execution continues to the next line.
And if it blows up, you also know where to handle that because that's the context where you are. But any other thing that does concurrent, whether it's asynchronous or threads or processes, introduces the problem that you don't know when it's done, and how do you handle the errors that they happen, I don't know, elsewhere, right?
And can you cancel it?
Yes, and how do you kill the thing?
Yeah.
And I guess I would add on top of that, what about effects?
Yeah.
Side effects.
Yeah.
Yeah.
Yeah. What's it doing to the
Yeah.
outside world?
Exactly. Yeah.
Yeah.
So this chapter starts with that discussion that was a suggestion from Bruce, and then I show a very simple, like small, like almost a hello world example in the sequential threads, processes, and asynchronous. And then I talk about the GUI, and then I implement a little program that checks large numbers for primality, and I show how threads don't work for that in Python because of the GUI. So then I do it with processes, and I do it kind of in a sort of a handmade way, because I build a queue manually, and then I do the thing, and then I explain. Okay, in the next chapter we're gonna see concurrent.futures, which is heavily inspired from the library in Java, and it does that for you. It launches the workers and creates the queues and manages that for you. But here we are doing it explicitly so that you can understand, because, for instance, the queue is a mechanism that is super important in any kind of concurrent programming for communication, right? And to get the results back from the workers and so on. So that's the first part of the chapter. The second part is where I talk. Okay, so but how about at scale? Then I talk a little bit about our architecture, which is not a topic in the book, but I decided to do that because I think I needed to cover that. Okay, because it's a matter of architecture. So, for instance, when you use one of those middleware softwares like GUnicorn, what they do is they launch several Python processes for you, and that's why people didn't need to know explicitly anything about concurrent programming and still do
horizontal scaling across cores in that case.
With Django, that didn't support any kind of concurrency mechanism, but
so you needed to show people, yes, this is single threaded,
yes,
but for a lot of use cases, you can just run multiple instances.
Exactly.
And you're going to then be able to handle 2, 3, 4, how many ever instances you want to run, the load through your HTTP process.
And so that part is split into different kind of domains. So, for instance, that's one domain of web APIs. The other domain is numerical computation. Then I talk about all the other things, the libraries that actually release the GUI, and then there's also distributed libraries that you can farm out jobs for lots of machines. And then there's the third part about Python usage in systems administration or DevOps, which is fine because you're telling machines to do stuff for you. So you can tell 1,000 machines to do this stuff. Because right. So
it's very
nice. Did you have another topic?
I did, which was the I can't remember the name. Python in the browser.
PyScript.
PyScript.
Yes. Well, I am super excited about PyScript because I think, for two reasons. As a teacher, when I often taught programming from scratch, I haven't done it in a while, but I want to go back to doing that because it's something that I enjoy. There's two things that are challenging to do that with Python these days, and the first thing is that setting up the environment.
The toolchain is
So to be able to do that just in a single file, that's like during breakfast today. I was joking about PHP. that was what was nice about it to get started, right? Because you have this file where you have everything, the HTML, the back end, the front end, everything, one file. Great.
Yeah.
Right? You get started.
Yeah. Yeah. I mean, you just install LAMP and start writing your PHP, right?
Exactly. Because people of our age, when we started learning to program, we would turn on a computer like an Apple II, and you would have these prompts to the basic interpreter. So that's it, right?
Yeah.
Very low barrier to entry.
Yeah.
So if I can write code in a script and open it in the browser and see it running, that's amazing.
Yeah.
And the second thing,
just creating that like super easy entry right into the language.
Yes.
Yeah. And with all the capabilities that you would.
Yes. So there's been Python interpreters or Python-like interpreters for the browser for a while.
They're probably just shipping it off to a server to then run the thing.
The people did like Brighton is a whole new interpreter, but it's not C Python, so it's not 100%. So I think the big advance now is that PyScript was built on other amazing work like Pyodide, which is built on top of Nscripten, which is this whole tool chain to compile,
to interpret Python
to compile the C code of the Python interpreter into WASM.
Oh wow! Okay.
And do that, and they're doing that because Anaconda is leading that. So that's really interesting because they have the power to do that for the entire ecosystem of scientific computation.
Yeah.
All of those libraries from Py to WASM, they're going to be able to make sure they work.
Yeah.
And so, but the second thing that also that also motivates me to dive into PyScript is between the first and the second edition of the book, I thought about writing a book for beginners, and
like people totally new to programming.
Yes. Yeah. And for instance, one book that I like a lot is Alan Downey's Think Python. Okay. And his book has a very permissive license. There's lots of variations of it. Think Java, Think Perl, Think I don't know. People are doing lots of variations, and I thought about I'm gonna do a Think Go.
Yeah.
But what I realized was that the kinds of examples that you can do with simple Python code or simple Go code is things that print to the terminal.
Yeah.
And if I thought about me when I was 15 years old, today, I think that's not a very exciting environment for a 15-year-old to learn to code.
I mean, even when I was learning Pascal.
What's a terminal?
They're used to a browser.
Yes, exactly.
When I started writing Pascal, my first language, I did not write terminal apps. I wrote things that put pixels on the screen.
Yeah.
And that was exciting.
Sure, exactly.
Way more exciting than text.
Exactly.
So the fact that so much of our learning now is just like text in a terminal, it's so boring.
Exactly. And for instance, the Apple Basic, right? So you could put pixels on the screen, and it actually, really, Steve Wozniak is a genius because he had this mode that no other computer at the time had, which was a hybrid mode where the top of the screen, 80% was graphic, and the bottom 4 lines were text.
Brilliant.
That's brilliant, right? Yeah. So then you could really interactively do things. So I want to do things that are graphical.
Yeah, visual.
Exactly. And to do that in Python, you have to choose one of those GUI
Which
libraries.
one's the best?
Yes, exactly. And then to do web work. Oh, okay. So you have this whole other thing of the web. It's just a mess. So that's why I think it's exciting because
this is, I'm sure, a reason why Jupyter notebooks and Python have been so popular. Is that with one line of code, you take a data set and render it in an exciting visual way.
A graph, an interactive graph.
Yeah, an interactive graph.
Yeah.
That's pretty darn compelling for a new programmer to be able to get so much value in visual stimulation, with so little code.
So I would recommend to everybody to watch Peter Wang's keynote at PyCon this year.
Okay.
I wasn't there, unfortunately, because of visa issues. But you were?
I
Did
was
you
there.
watch it?
Yeah, it was very exciting.
The
Jeremy
video,
and I both saw it. Yeah.
yeah, the video is great. Just I recommend that people go watch it because he does some amazing demos. Right?
Oh yeah, it was like, whoa, finally, this is happening.
But people need to understand that PyScript right now is very rough, right? It's like pre-alpha. They're figuring out a lot of things, but I think I'm excited about it.
Well, and the response to the keynote was huge, and I think that gave whatever the company is, Anaconda, just a lot of. They go, oh yeah, this is a good place to go.
Yes.
So I think they are putting lots of effort behind it.
Yeah. But I had talked to Peter before.
Mm-hmm.
I had a one-on-one with him once because I was talking to Dave Beasley, this other Python author, that about some things about being more friendly to beginners. And he said, oh, you need to talk to Peter Wang. So I didn't know about Peter Wang. Then I found out he was the CEO of Anaconda. So about a couple of years ago, I had a 1-hour conversation with him about things that I loved about, for instance, HyperCard. How it was a very approachable, like a gradual, where you could learn gradually, do interesting things with the first concepts that you knew about, and then grow into it. And and he was that was also his concern, so they know that this is going to be huge for people to get started.
Well, or develop
exactly.
actual apps.
Like for instance, in many colleges in Brazil, for instance, it's super complicated to convince the IT department to allow to install something new on the lab machines, right?
Yeah.
And just the browser.
More constrained environment.
Oh yeah. So
it's funny how the things that have nothing to do with the technology or very little to do are blockers.
The politics, the bureaucracy,
IT,
those guys.
So
what a bunch of bastards.
Have you turned it on and off?
So PyScript does sound super interesting.
Yes.
But I did want to come back real quick to CPython, or you called it?
Yes, CPython is the main interpreter written in C.
Okay.
Yeah.
And is that the standard today, or is that kind of the more high performance?
No, it's the standard.
Okay. But then there's also a new alternative to that, which is like Python on Python.
Yeah, it's PyPy.
PyPy. And then tell me more about that and what's exciting about it, because I've heard.
Okay, it's really interesting. So PyPy is written in a subset of Python that they call RPython, and then there's this hugely complicated tool chain that, if you really want to compile it from scratch, which they don't recommend, takes hours.
Okay, wow.
But the thing is, this is a Python interpreter that includes a just-in-time compiler.
Okay.
So it can be much faster than Python in many cases.
Okay.
But the main drag to its wider adoption, a lot of important projects use it in production and so on. But the main problem is that a lot of the external libraries that we are talking about that are super important are not compatible with it.
Okay, because it uses a subset or requires a subset, or
because the internal APIs of it are just different.
Not there yet.
Yes.
Yeah.
And they
want to be there.
It could, but and they have been very influential into advancing those external APIs for CFFI in order to make it easier for extensions to work both with CPython and PyPy. But it's still
the long-term future PyPy. Is that where?
I don't think so. Uncertain? You know why? Because over the years we've seen very small adoption from the core developers of that, and the community around the core of that doesn't grow.
Interesting.
I think the tool chain, everything around it is
just too
complicated. Yes.
Yeah.
So, but what's happening now, which is really interesting, is that Guido went to work for Microsoft. Right? Guido retired, and then Microsoft made him an offer he couldn't refuse.
Well, he told me this. He specified.
Yeah.
I will work. I don't know what he said. 22 hours, 24 hours a week.
They allowed
Yeah.
some
Okay.
And they go, sure.
Yeah.
And he goes, okay.
Yeah.
Because then
But-
it fits with his lifestyle.
But
So
also, I don't know if he negotiated that, but also
He
he
did.
created a team, right?
his
There's
own
a team around him.
Yeah.
And
Mhm.
It's-
and he built it himself.
yeah.
Yeah.
Huh.
Yeah.
Oh, that's cool.
And so they are, and one of the people he brought in is, what's his name? I forgot now. But he's a guy who had previously, like, I don't know, 6 months or a year before Guido joined Microsoft, he had made a proposal that he wanted $500,000 to make Python 50% faster.
Okay.
And people didn't mostly say you're a lunatic because they knew his contributions before, and so most people said, yeah, he probably can pull that off,
Yeah.
But now he's doing it for Microsoft.
Okay.
Mhm.
I mean, for everybody, which is
Mhm.
great, right? Because
Because the version that's in beta now is a lot of performance improvements.
yes,
Must be
this
his
is
work.
happening now. There's a
Mhm.
lot of
Mhm.
sure.
So as we wrap up, any other things that are on the horizon that are exciting in the Python world?
I mean, there's a whole bunch of peps. There's always peps.
Always peps.
Yeah. When I was at the Python conference, we talked to Jim Baker, and he had a proposal that sounds really interesting, and it's about string interpolation, but you can build your own interpolators
Oh, cool.
and have them, and that could. I mean, so many people use it for this kind of processing that could. And there's also type checking involved in it,
cool.
so the reliability of
I think
the
I talked to Jim when he was up in Crested Butte about this and told him to check out what Scala had done.
That might have inspired his idea because, I don't know if it's a proposal yet, but Guido was very excited about that as well. So I think it's going to be very interesting and a very different way that, it's like, never even occurred to me to do that, but I can see the value of it.
Yeah, so we don't have a lot of time to talk about that, but I'm going to suggest that people take a look at PEP 695 type parameter syntax, because that's going to do away with the need to have this weird type var class that you have to import from the typing module to click their type vars.
Yeah.
You will be able to use them in a more natural way, like in Java.
Yeah.
And that's going to be huge, I think,
cool.
for people who like static typing.
Yeah.
It's going to be a great improvement because it's going to, look at this first example. You have 3 lines of code, kind of long ones even.
Going to one
Going
line
to
with
one.
very concise syntax.
And because
looks similar to like other languages and how they do.
And it will also free lots of people from having to understand what covariant and contravariant means.
Yeah.
Because they discovered that they can infer from the methods. Yes.
Oh,
from the usage. If it's
the usage. Yes. Yeah.
Interesting.
Exactly. Yeah. So that's a good thing. Yeah. I personally, in my travels with Python, I'm excited about learning Rust to learn to do Python extensions. Yeah. That's what my personal next focus is.
Nice. Excellent. Well, that's super fun.
Yeah,
thank you,
Luciano.
So much. Good to have you in Crested Butte.
It's amazing to be here with you guys. Thank you so much.
Thanks.
Okay.